Hi, this is my first video on solving trig equations. In this video, I'm going to discuss all techniques and steps you need to know when it's come to solving trig equations. Okay, so the first thing you need to know when you solve trig equations, maybe you will see sometimes very complex trig equations, but if you want to solve them, you have to simplify those equations and get some very simple equation in these forms. The first form is sin x equal to k, right? So here this k should be between positive 1 and negative 1. So this should be greater than to negative 1 and less than to 1, because you can see that in this graph, y equals sin x graph, for any value of x, sin x varies between 1 and negative 1, right? So if you want to solve this equation for this variable x, you need to make sure that k is between negative 1 and positive 1. And that is the first form you would get when you solve trig equation. And second one, you will see that you would end up with this kind of simple equation, cos x equal to k. Here again, this k constant should be between negative 1 and positive 1. So because you know that even cos function, cos x, varies between negative 1 and positive 1 for any value of x, right? And the third case is you would get this kind of equation, simple equation as tan x equal to k, right? Here this constant can take any real number, because we know that tan x can take any real number between negative infinity and positive infinity, right? So now let me take this example. We first, in this video, we're going to discuss this type of trig equation, sin x equal k, right? So essentially k can be negative or positive between 0 and negative 1, or 0 and positive 1. Okay, so let me take this equation first. Let's say we need to solve sin x equal to half, right? So solving this equation means we have to find all angles x values, right, which satisfy this trig equation. In other words, when you find solution to this trig equation, there are always angles for this x. When you substitute those angles, you should get half. Okay, so now if you go back to your GCSE, you learn how to find this angle x. So we can write angle x as sine inverse half. If you use the calculator, you can get this angle x as 30 degrees, right? Now, I'm going to ask this question. Is this only solution you can get for this trig equation? Actually, it's not. Because, let me draw this line, sin x equal half, or we can say y equal half. I'm going to draw this line here. Now you can see that this line y equal half cut the graph at this point, right? So this angle actually corresponds to this solution. This is 30 degrees. And you can see we have another angle, right? That gives us half for the sine function. So we can actually read this angle. You can see this is 30, same, this length is 30. So we can get this angle as 180 minus 30. So that's 150 degrees. So even you can see here, we're going to get another angle. And we know that sine graph is continuous graph. It's going up to plus infinity this side. Even we can get actually many angle, right? From this side, they are negative angle. So actually you would get infinitely many solution for this x, right? For this x. But it is not possible to write all those angles as solution to this trig equation. Therefore, in the future, you will see that when they ask you to solve this trig equation, okay, they would advise you to write solution in particular interval. So I can say that if I want to write solution between 0 and 360, we have only two solutions, right? So we're going to solve this equation in this interval, x less than equal to 360 degrees and greater than equal to 0 in this interval up to here, right? So when they ask you to solve this equation in this particular interval, we can write solutions. We have another solution as x equal 150, right? So when you solve trig equation, basically you can sketch the graph of sine x, right? You can get solution like we did here. But this is not very convenient method because you need to sketch graph of sine x, sometime graph of cos x, tan x to get solution to this trig equation in the given interval. We have another method to solve trig equation. There we're going to use cast diagram. So that method more convenient and it's actually faster. So in the future, we're going to actually use cast diagram method to solve trig equations. Here, let me explain that method. First, we need the cast diagram, right? So here we have cast diagram. We have, this is the first quadrant, second quadrant, third quadrant, fourth quadrant, right? So we're going to use this diagram to find solution to this trig equation sin x equal half. The first step is, as we did here, we're going to use the calculator to find the first angle. That first angle we call as principal angle. So this angle we call as principal angle. We're going to use that principal angle to do this. What I'm going to do, I'm going to draw two cross lines through this origin like this. Right? Now, what I'm going to do, I'm going to take these angles as we need to make these angles same, right? And also we need to take those angle, measure those angle from this x-axis, right? So we put these angles as 30 principal angle. I'm going to fill here. Always we do the same thing, right? Now we need to pay attention to this. One thing is we need to look at this value. You can see it is positive value. We need to decide which angle we're going to measure. Now we know that sine positive in the first quadrant and second quadrant, because in the first quadrant all ratios positive. Therefore, we know that sine positive. Even in the second quadrant, sine positive. So we need to get angles from the first quadrant and the second quadrant. Let's see how we can get those angles. We need to now look at this interval. That is important. we can see that we have to write all positive angle between 0 and 360. So we're going to measure positive angle from this positive x-axis. To get angles in this interval we call positive angle, we need to measure those angles anticlockwise. So we start measuring from this line, and when you meet this cross lines, you count the first angle, right, if it is in the relevant quadrant, because we need to count angles from the first quadrant and second quadrant. When you start to measure those angles, I can see I meet the first angle in the first quadrant, and if you measure another angle in the second quadrant, you meet this cross line. So we're going to take this angle as the next one, right? So now we can write solution to this trig equation sin x equal half using this cast diagram. So solutions. So the first solution is here, this is 30 degree, and second solution here, how we can read this, up to here 180, right? This angle is 30, therefore we can get this angle, it should be 180 minus 30, right? So we can write solutions x equal to 30, and other one is 180 minus 30 degrees, so that's 150 degrees. So this is actually more easier than drawing graphs. Right, let me take this example. We have to solve sin x equal to root 3 over 2 in this interval, right? So we're going to use cast diagram. When you use cast diagram, you need to pay attention to this. Now you can see that our interval from the negative side. So basically we need to find negative angles, okay, as solution to this trig equation. And other thing is you need to pay attention to this. So this is positive value. Basically we're going to first see in the cast diagram where sign positive, right? So let me take the cast diagram. Okay, so here we have cast diagram. We know that in the first quadrant sign positive, right? This is the first quadrant, second quadrant, third, and here we have fourth quadrant. Okay, so first quadrant here. So we know that sign is positive in the first quadrant, right? Because all positive, here all positive. And in the second quadrant, sign positive. So basically we need to find angles from the first quadrant and the second quadrant. That is the first thing we need to notice, and we need to make that decision. And this is important. Have a look here. We need to get negative angles. How we can measure negative angles? We discussed that. We need to now measure angles from this positive x-axis in clockwise direction. Okay, but we have to get those angles from first quadrant and second quadrant. How we come to this first quadrant and second quadrant is basically this way, clockwise, right? So let's see how we can do that. I'm going to take this equation here. We have sin x equal to square root 3 over 2. Okay, so I'm going to find the principal angle, x equal to sine inverse square root 3 over 2. When you use the calculator, you would get this angle as 60 degrees. Now, what we have to do next? We have to draw these two cross lines through the origin, right? Why we do that? It's help us to read required angles. Basically, those are solution to this trig equation, right? So next thing, I'm going to put these 60 angles here, right? Like that. Then I'm going to come to this quadrant all the way up here. This is one solution. And we can come to the first quadrant clockwise all the way up here. Now we need to read these two angles. Those are solution to this trigonometric equation, right? So very simple, very quick. And how we can read this angle? So up to here, when you come clockwise, up to here it's minus 180 degrees, and we get this another 60 degrees in same direction, right? So it's going to be now minus 180 minus 60. So that's going to be negative 240 degrees. That is one solution. And you can read this angle. So if you come all the way up here, right? So that's negative 360. And here we have this angle. We need to take away this angle, right? So that angle, if you measure this angle, it is plus 60 because I need up to here, right? I have to come up to here. So I can add this angle 60. So that gives us negative 300. So after that, we can write solutions. X equal to minus 240 degrees. Another one we can write minus 300 degrees. Okay, so we have two angles. Those angles satisfy this trig equation in this interval. All right. Okay, now let me take this example. This is a little bit different now because we have sin x equal to negative 2 over 3. Basically, k is negative here, right? So we need to find all angles in this interval. Okay, so again, we're going to use cast diagram. Okay, let's see how we can use this cast diagram to solve this trig equation. What is the first thing here? Let me take this equation here, sin x equal negative 2 over 3, right? I'm going to write solution to correct to nearest degree, right? First, I'm going to find the principal angle, x equal to sine inverse negative 2 over 3. So use the calculator for this. Right, I'm going to write the solution to this x as negative 42 degrees, correct to nearest degree, right? So this is we call principal angle. Right, so we're going to actually use this principal angle to complete this cast diagram. So always same thing, I'm going to draw these two cross line, right? Now what I'm going to do, I'm going to remove this negative sign and I'm going to fill these angles as 42. Remember that if you get a negative angle, that's what we do. We take the size of that angle without the sign, okay? We're going to fill these angles as that. So we have 42. I'm going to write 42 here. All these four angles. Right, it's just to help us to read the required angle. Now, another thing we need to carefully look at here, two things basically. One thing is we need to look at this value. So we need to decide, now you can see value is negative. We need to look at the cast diagram and decide where sign is negative. We know that here sign positive and here sign positive. In these two quadrants, sign negative. So I'm going to note that here sign negative. So I need angles in the third quadrant and fourth quadrant here, because in the fourth quadrant sign negative. So I notice that, right? Note that. And other thing is, we need to get angles, essentially they are positive angles. So we need to measure angles from this line, right, positive x direction, anti-clockwise. I need to come up to the third quadrant and I need to come up to the fourth quadrant. We need to read these two angles. Okay, let's do that. So I have this angle, right? We can read that it's going to be 180 plus 42, and we can get this angle. We can read it here. It's going to be, we know that up to here 360, so we can actually take away this angle to get this angle. So you can see when we draw these two lines, it's help us to basically get these solutions. You can see that when we put these angles like that, even that help you to read the required solution, required angles. Okay, so now here this angle going to be 360 minus 42, right? So I'm going to write those solutions here. The first angle I can get from here, right? We add these two angles together. So you can get the first solution from here. It's going to be x equal to 222 degrees, one solution. And you can get the second solution. You need to take away 42 from 360 degrees. That's 318. Okay, so we have two solutions to this trig equations in this interval.